Okay, today what we're looking at is determining if a correlation exists between variables. So in other words, is there actually a relationship between two variables or not? And sometimes that's a little bit difficult to tell. All right, so the first thing we're going to look at obviously is scatter plots. And again, you're getting quite good at them, so this shouldn't be that difficult, hopefully. Okay, we already know that scatter plots represent two variable data as points. Okay, so we looked at that yesterday when we were determining whether something was one or two variable. Okay, when we're looking at scatter plots and we're talking about two variables, one variable is going to be dependent on another variable. So we have what we call a dependent and an independent variable. And sometimes also that's a little bit difficult to determine which one is dependent on the other one. So this is the slight definition of what we're going to look at as being what our variables are. So first of all, an independent variables exist on their own and are not influenced by other factors. Okay, so they exist on their own. So examples of that could be things such as time, the year, a person's age. Those exist no matter what happens. Okay, and when we're looking at dependent variables, they rely on other factors. So, for instance, for those of you that work, the amount of your paycheck depends on the number of hours you work. So the number of hours is independent. Okay, so that doesn't change, but the amount of your paycheck changes by the number of hours you work. Now, when we're actually graphing these, and this is from science as well, you should understand that we have our independent variable, and we have to know what axis it goes on, and we also have the dependent variable. So the independent variable always is on the horizontal axis. Now, if we were talking about the Cartesian plane, our independent variable is our x. X is going to exist. Okay, time is going to exist no matter what. So that it goes along the horizontal axis, and the dependent variable goes along the vertical axis. And obviously, if we're looking at the Cartesian plane, that's the y. Now, if we look at this example here, the amount of a paycheck depends on the number of hours of work. What would happen here is the number of hours of work we would put along the horizontal axis, and the amount of the paycheck then becomes the dependent variable, so it goes along the vertical axis. Now, the next thing we're going to look at is the type of correlations. Now, there's a few different ways to look at that, and I'll talk about this as we go on. But first of all, a correlation is if a relationship exists between two variables. Now, because the data, or in other words, the points are based on real data, on real things that we've collected, the points usually do not exactly fit an equation. They just don't. Okay, so all the time you've been working with X and Y, that's a perfect situation, that's a perfect equation. However, in the real world, things are not perfect. So this, however, doesn't mean that it stops us from doing an equation that best fits the points. And this happens in the real world. It happens in determining how much you pay for your insurance, car insurance, all those things. So let's look at the first scatter plot. When I see a scatter plot like this, first of all, to me, it looks like there is no relationship. There seems to be points everywhere. It doesn't appear, is it going up or is it going down? Is it a circle? Which wouldn't be a relationship either. So what that means is you do not make an equation. So if you made an equation for this, that would be wrong. Okay. Then what happens is we have two other things that are going on here. When I look at these, they both look like they're kind of going upward. So the first one we would say that has a strong, as soon as I find my thing, a strong positive relationship. The points are together very loose, or sorry, very tightly together, and it's going in a positive direction. Compared to this one, it's also going in a positive direction. However, I would have to say that it would be weak. So it's a weak positive. Now, what that means when I make an equation, I can make an equation for the strong one, and it should be fairly accurate to make predictions because all the points seem to be fairly close together. So it appears that I should have an accurate prediction based on whatever equation I make. The weak positive, however, may not be good at making predictions. Doesn't mean that I won't necessarily do it. It just means that if I'm making decisions, I might be a little more cautious about those decisions that I make. Then if I look at the bottom two, okay, again, you can see that they're going down. And so I would say, for instance, this one is a strong negative. Okay, again, the points are close together and it's decreasing, so it tells me it's negative. The other one I would say is a weak negative. Again, it appears that it's going down, a downward trend. However, the points aren't close together. Just like when it was strong positive and weak positive, my strong negative means that I should have accurate predictions, and the weak negative means that it might not be very good at making predictions. Okay, the next thing we're going to look at, and again, has to do with the types of scatter plots. And you've done this already in another unit. So again, I'm just going to go very quickly through this. Okay, when I look at the first one, it appears to me that it is linear. It also appears to me as if it's positive. So I can see that this scatter plot represents a linear type of relationship. If I look at this one, again, linear, negative. This one here, a little bit harder to say. So I'm going to say no relationship between here because it looks like I could go up. It also looks like it could go down. So no relationship. It doesn't mean that I can't make a scatter plot. It just means I shouldn't make a line of best fit or an equation of best fit based on what I'm seeing. Okay, the bottom row is a little bit harder because we have things such as quadratic and exponential. And sometimes when we're just looking at a piece of the graph, it's hard to say. Now, this one here could go back up, or it could just trail along that x-axis. I'm going to say for this one that when it comes up, properties, it doesn't want to show me what it's doing. Oh, there it is. It's exponential. And as I said, for some reason, it does not want to show me what that is. And let me play one more time with it. Exponential. There it stayed. Now these two here, I'm going to say that they are quadratic. And again, it's a little bit harder to see that because I'm only seeing bits and pieces of it. And I'm sorry about that, but I'm not going to restart everything again. So I'm going to say that both of these are quadratic. But again, as I said, it could be this, especially for this one because it's going down again. And it could be this one. Well, no, actually, that's not true. It really shouldn't be this one because if I think of um, exponential decay, it starts up a high, but then it swoops down, and you can see that's not happening here. So I definitely would say this one is not exponential, but this one and possibly this one are exponential. And the same thing when it comes to quadratic. This one could be quadratic or this one. But I think the middle one, I would have to definitely say that it's quadratic just because it does not decrease the same way as an exponential does. So have some mathematical pleasure now And if you have any questions, make sure you're asking.